Hello, everyone, and welcome. Thank you for attending the Vision Spectra conference. Today, we will be exploring remote control lenses. My name is Jonathan Hackney, and I will be your host today. I'm one of the sales directors here at Computar. I have a background in industrial engineering, and I've spent the last 15 years of my career in the manufacturing and automation industry. Computar, for more than 40 years, Computar Optics, part of a global conglomerate, CBC America, has been a worldwide leader in developing innovative lenses. With its technical expertise, Computar Optics consistently engineers superior optics and custom lenses. So we're going to be talking about remote controlled lenses today, but why would you use a remote controlled plug and play lens? Well, let's talk about some of the problems that one might encounter in some of their vision systems. So one of the top three problems is low visibility. So the current lens, it might be old or worn out, where the application might call for a high resolution. The second, the lens might be in a high or hard to reach spot. So now every adjustment might carry some type of safety risk or cost associated with it. And the third is lack of customization. So older and manual lenses might not be able to adjust their focus in day-to-day operations. So one application might be on a conveyor belt, say where the ideal part might vary in height. And that type of customization might be very useful for you guys. So let's look at some of the applications and some of the test studies of some of our best customers that are currently using some of these LensConnect lenses. The first that we'll talk about is Microtechnica. So this manufacturer had several challenges in their vision application. They needed a solution that was versatile, flexible to mount on a robot arm. They needed a high quality image and high resolution for barcode reading and OCR. And they needed the system fully integrated and automated in their manufacturing operation. So with our LensConnect lineup, Microtechnica was able to have multiple choices to accommodate their application. With high resolution LensConnect, they were able to read barcode with extreme accuracy at 3.4 micron and higher. And with our I2C interface, we were able to fully integrate and achieve great repeatability. The second case study that we'll talk about is Artemis Vision. So this OEM overcame multiple challenges using the LensConnect. Their application required continuous adjustments due to the very object size and distance. Our solution was the varifocal LensConnect, the VL6Z 26UC, which is this bad boy right here. So this guy is 16 to 96 millimeter focal length. So now they can change the FOV, the iris, and achieve a wide angle image with the 1.1 inch 16 megapixel sensor. This next case study is Maxwell Frontier. So with the LensConnect, Maxwell Frontier was able to motorize the iris and focus to help inspect the varying parts. Maxwell Frontier also utilized the USB interface with its easy to understand API. They were able to fully integrate the software directly into their system. So with these case studies, the plug and play LensConnect is able to provide a number of solutions with high resolution. So from anywhere from 5 to 20 megapixel, we have remote adjustments, focal lengths from 4 to 96 millimeter, and user-friendly software, which is free, and you can download the SDKs off our global webpage. So Computar's genius innovation with this lens has earned a Vision System Design Innovators Award as well. In this slide, what I wanted to show you guys was basically a standard C-mount lens compared to the LensConnect. So on the left, you'll see a standard C-mount lens. And then on the right, you'll see that same C-mount lens, but in the LensConnect form. And already you can notice its slim, sleek profile. So it can basically be mounted, and you won't have a lot of size restrictions, even though you're going to have several stepper motors inside that lens as well. Taking a look at the inner structure here, as you can see from the illustration, the LensConnect is surrounded by a metal housing casting that protects the LensConnect and the PCB board and stepper motors. So a stepper motor is assigned to each function, whether it's the zoom, the focus, or the iris. In this slide, you'll see the connection diagram. So you'll see how the LensConnect is connected to the camera through a C or a CS mount. Then a USB extension is used to connect to the PC and allow the user to communicate to the lens. Our software SDKs can be downloaded for Windows or Linux, as well as other machine languages. And we can also provide the source code for this software. We also have a I2C connection available as well. So how do you use the LensConnect? The LensConnect is extremely easy to use. The first thing you're going to do is just attach the lens to the camera, right? Next thing you're going to connect the lens to the PC or PLC. Next you're going to initialize the lens in the software. And finally, input your desired values for the positions of the iris, the focus, and the zoom. Our software is extremely user-friendly. So this is an actual screenshot of the software. It is compatible with both Windows and Linux. Like I said earlier, we have the open source code, and it's available for full customization and integration. The remote zoom, focus, and iris controls are as you see it here in the screenshot. So you can set your stepper quantity, you can enter in the exact address, or you could use the slide ruler here to make your image adjustments as well. So from our global webpage, which is computar-global.com, you can download the LensConnect controller software, the user guide, the protocol guide, and the API documentation for free. So I've given you an introduction to the LensConnect, but how does it work exactly? Well, the stepper motors, they move in fixed increments. So the lens can return to a specific position with a high degree of accuracy. It uses a floating focus design, so it can deliver ultra high resolution from near to far. This lens also uses digital signals, and it moves a set number of steps from a known position, so there's no need for feedback signals. And it also has quick response time. So once a new address is entered on the zoom or iris or focus, it's on the zoom, iris, or focus control slides. They immediately go to those positions. So very quick response time. The Computar LensConnect is also compatible with multiple OEM cameras from different manufacturers, including Brasler and Dahing Imaging. The image on the left shows our varifocal or 16 to 96 millimeter, 1.1 inch, fitted with a Brasler camera at the Vision China trade show in Shenzhen, China. The image on the right shows our 1.2 inch 24 megapixel model at that very same show. Here's another example of some camera OEM manufacturers that are utilizing the LensConnect. This is Omron Syntec. it's another example of that. They adopted the LensConnect into their vision system lineup. Here's an example of Syntec using our 1.1 inch 16 to 96 millimeter varifocal LensConnect. This was taken at the Image Fencing Show in Japan this year. So next, I'd like to highlight Computar's LensConnect future. So we are seeing exciting expansion and growth for zoom lenses that have a high zoom ratio and close macro. So we recently developed a sample for a telecentric model for the LensConnect, eliminating the need for a Z-axis stage. This telecentric model is in the mass production phase currently. We're also exploring options for embedded vision applications, and we've developed several prototypes for an S-mount LensConnect package, which is really cool. So we've expanded on our connection capabilities as well. So we've developed connection devices that now allow you to communicate to your PLC or to your computer using RS-232, RS-485, and Ethernet IP. And we also have that I2C connection as well. And lastly, we've made advancements in image processing, including lens aberration correction. So some examples of those advancements in image processing are shown here. The image on the left, it shows normal distortion, and the images in the center and right show the distortion correction. So in the image in the center, we've corrected the distortion and cropped according to the horizontal field of view. With the image on the right, we've cropped and maintained the aspect ratio. So not only have we corrected that pin cushion distortion, but we've also the vignetting and the lateral chromatic aberration, and then the EIS, or electronic image stabilization. So this is done by reading the characteristic data of the image in the lens PCB board and then processing through the software. So next, let's talk about the LensConnect product lineup. So right here, you're going to see our DL and our VL series, or the MPY and the MPZ series. So the MPY series has a high resolution, 12 megapixel, 1/1 inch, and then we have our 2/3 inch as well. And these are all monofocal, so fixed focal. So we have the 8 to 50 millimeter, and on the MPZ version, the 1 inch and 1.1 inch, we go up to 20 megapixel, and we also have an 8 millimeter all the way up to 75 millimeter versions of this monofocal product lineup. As for our varifocal product lineup, we actually just made a couple of these new ones here. The top two are going to be a varifocal from 12 to 36, and then a 5.5 to 12.7. These sensors are a 2/3 inch sensor with a 9 megapixel resolution. And then we have some of the other ones that are almost some of our older LensConnect legacy. So the 1.1 inch, 12 megapixel, the 16 to 96 millimeter. We have a 1/1.8 inch, two of them that are both 5 megapixel. One is a 4 to 10 millimeter focal length, and the other one is a 9 to 50. And then we have this 25 to 50 millimeter as well, this 1 inch as well. The MLMUC 3Z MPW, that's our telecentric model that we just developed over there on the right. You'll see it right there on the right as well. So for some reason, the machine vision industry has a high demand for motorized lenses, and we've started the adoption of universal interfacing, such as RS-232, Ethernet IP, and I2C as well. The driver board is already built in, and the API and sample programs are free with the LensConnect. The LensConnect is going to offer you a high resolution for your sensors as well. So it's a great lens as far as high resolution. And the expansive variety of the LensConnect models can help you in very diverse applications. So it's going to save you guys money and increase efficiency. Um, so for the LensConnect, um, we see that we love the expansion and the excitement here, and we'd love to kind of hear and talk about some of your applications with us. We're going to do a small Q&A as well. So if you have questions, please enter them into the chat, and we'll answer some of those questions. And then if you guys maybe you don't want to answer in the chat and you want to send me an email, here's my contact information right here. Phone number is 919-414-8098. And then my email is jhackney@cbcamerica.com.